to identify fundamental causes that resort to the principle of structural modeling. Consider the classic problem of identifying the total effect of distal causes in the presence of intermediate causes, also known as mediators. In the model on the left, which estimates the total effect, only confounding factors or effect need to be controlled. However, the direct effect can be estimated after controlling for mediators. The difference between the two estimates gives the indirect effect of distal causes. This simple and canonical example shows how to statistically identify direct and indirect effects by combining directed acyclical graph analysis and regression analysis, or in other words, non-parametric causal analysis and parametric analysis. This type of analysis is known as structural equation modeling, or SEM for short. Here is an example illustrating how structural equation modeling helps identify the effect of socioeconomic status on smoking. The causal graph appears awfully complex because it uses a large number of explanatory variables. However, the actual model groups them into latent variables which are easier to interpret. In this version of the causal model focusing on latent variables, the total effect of socioeconomic status cannot be estimated if other parameters, in blue in the graph, are included in the model. The total effect of distant determinants is often underestimated in regression models, as indirect effects are absorbed by intermediate determinants. In this example, socioeconomic status influences all other variables, which may themselves influence each other. In the literature on causality, this is referred to as the Table 2 fallacy, in reference to the regression table that reports the effect of all variables without consideration of their causal interrelationships. Behind this problem also lie differences between the logic of the social sciences and theories, which tend to seek distant or fundamental causes, and that of the health sciences, which are, for practical purposes, interested in immediate causes that can be acted upon as close as possible to their effects. This causal diagram presents in a simplified way the empirically estimated correlation between the different variables. The direct effect of SES on smoking is represented by the green arrow. We can see that there are many other paths that leads to smoking through other latent variables. The causal links between these variables can be positive, negative, or nil. In addition to the direct effect, first-order effect of socioeconomic status on smoking, the tables shows the indirect second-order effects of socioeconomic status through other variables, as well as the third-order and fourth-order effects, which add up to form the total effect. The higher the SES, the less common smoking is. The total effect can therefore be broken down into a direct and second or higher order indirect effects. Each effect can be estimated empirically and added up according to the order of the effect. In this example, the direct effect accounts for approximately 66% of the total, the second order effects for 23%, and the remaining orders for 11%. The total effect of SES would therefore be underestimated by 1/3 if all variables were naively included in the model without taking into account their mediating role.